Assalamualaikum
Assalamualaikum
warahmatullahi
warahmatullahi
wabarakatuh.
wabarakatuh.
My name is Willa Cahyadewi, and I'm going to tell about introduction of alkenes.
My name is Putra Wijayakusuma. I would like to tell you about oxidation of hot potassium manganate.
My name is Putri Faizah Shafira, and I will gonna explain you about the cold potassium manganate.
Hi, my name is Willa Cahyadewi, and our group will be explain about the oxidation reaction of alkenes. But before that, we need to know what is alkenes, and I'm going to help you to understand about the introduction of alkenes. So, what is alkenes? Alkenes are a homologous series of hydrocarbons that contain a carbon-to-carbon double bond. Hydrocarbons mean it only contains carbon and hydrogen atoms. For example, first is ethane, second is propane. As you can see, there is a double bond between the carbon-to-carbon atom, which is identified. There is an alkene. Next is alkenes properties. The general formula of alkenes is CnH2a. Alkenes has double covalent bond. It have both one sigma and one pi bond, and the hybridization of alkenes is sp2. Due to the double carbon-to-carbon bond, alkenes is unsaturated hydrocarbon. This bond is why the alkenes are more reactive than the alkanes, because the alkane just has one single bond. Alkenes used as the synthesis of alcohols, plastics, liqueurs, detergents, and fuels. The boiling point of alkane is higher than alkene due to size of the molecules. Next is alkenes reaction. Alkenes reaction divided into two. First, we have addition, and second, it is an oxidation. But our group just only explain about the oxidation reaction of alkenes. The oxidation of alkenes is divided again into two. First is hot concentrated manganate solution will be explained by Putra Wijayakusuma, and second is cold concentrated manganate solution will be explained by Putri Faizah Shafira.
Hi, so it's me, Putri Shafira, and I'm gonna explain you guys about oxidation of alkenes by cold acidified KMNO4. So, the content is separated into two parts, which is introduction of cold condition, and the second one is exercise. Part 1, Introduction. Using cold and dilute KMNO4, which is sometimes called Bayer's reagent, oxidative addition occurs where the pi bond of double bond break to have hydroxyl functional group. Attached to both carbon that used to participate in a double bond, this mechanism forms cyclohexane 1,2-diol. If you have any alkene here, and you are using cold dilute KMNO4, this observe the cleavage of pi bond only. In here, I already crossed the C double bond with my red pen. Hence, the result is the molecule remains in that to the sigma bond, and instead of the pi bond, you'll end up in a diol. This is also called as a vicinal diol. This Bayer's reagent is in the purple color solution, and the result is in the colorless solution. This reaction can be used as a test to find out whether a compound is unsaturated or no. So here, the simple description which resulting alcohol diol using cold and dilute Ka-MnO4. So first, let's take a look at the cold condition here. What's going to happen? So we've got cyclohexane here, and we've got potassium permanganate in basic condition. So we've got sodium hydroxide there, and what it's going to achieve is a syn dehydroxylation. This is the permanganate ion, and so it's actually very similar to the addition reaction we already know for syn dehydroxylation using osmium tetroxide. We already know how to do that. And the reason that a syn dehydroxylation is because both the oxygen that are being delivered to the molecule are coming from the same molecule. So it has two kind of lower down, and it's just a liver spot oxygen. So actually the permanganate ion going to do exactly the same thing. We've got two oxygen that are being delivered to the molecule, so we're gonna get this syn dehydroxylation resulting in this physanodiol. So just remember, when you see potassium permanganate operating on an alkene, if conditions are cold, very important that going to be a syn dehydroxylation. So here I have an example for you guys. This alkene, in this case, if you are using a Bayer's reagent, it is Ka-MnO4 solution, which is cold dilute. This will result the molecule formed as product would not have the P1. Instead, the P1 you will have two OH group. 1, 2. There are two of them which attach to the carbon, and this end up in a diol.
Okay, so I will explain to you the oxidation of alkenes by hot acidified potassium manganate. So first, I want to introduce you to the very easy concept for finding the product of oxidation of alkenes by hot potassium manganate. Here, there are three ways to know the product. So, yeah, when you want to ask what is the product of these alkenes when it oxidized by hot potassium manganate, yeah, so first you have to split all the double bonds in the alkene molecules, right? Yeah, so when there are two double bonds, yeah, just split the two double bonds. When there are three double bonds, split all of them, right? And second, you have to identify the elements or group that may attach with the double bond carbon atom. Is it alkyl groups? Is it hydrocarbon groups? Is it hydrogen? Right? So you have to identify the elements or groups. Okay? And finally, you have to look at this table. I have summarized the oxidized product. So as you can see that when CH2 double bond is oxidized, the oxidized product will be CO2 plus H2O, or sometimes in AS level examination, we also rarely to write the water. So yeah, you can just write the carbon dioxide, okay? And when C double bond attached to the alkyl or hydrocarbon groups and attached to the hydrogen group single bondly, the oxidized product will be in terms of carboxylic acid. And last is when the double bond carbon atom attach with two alkyl or hydrocarbon groups, so the oxidized product will be in terms of ketone. So I will show you the example of two questions, right? So here, this is the molecule of alkenes, CH2 double bond C single bond with alkyl and hydrogen atom, right? So first, remember that you have to always split all the double bonds in the molecules. Here, there is just one double bond carbon atoms. I mean, there are two carbon atoms, but just one double bonds, right, in this molecule. So when you split the double bonds, it becomes into two molecules. The first molecule is CH2, and the second molecule is carbon attached to the alkyl groups attached to the hydrogen group single bondly, right? And then you have to identify the elements, right? So the first molecule is CH2. It is clearly written in the table, right? The product of CH2 when it oxidizes is CO2. And then for the second molecule, the product will be in terms of carboxylic acid, right? And yeah, in the second example, you can do like that, right? So yeah, just try yourself by the example. And I want to let you to practice some questions. Okay, all right. So this is the first question. Okay, and in the right side, there is the answer, right? So you should draw the structure of the organic molecules produced when dodecene reacts with each of the following reagents. Okay, so just focus on the hot concentrated manganate ions, right? Okay, and same with I have explained to you. First, we have to split the double bonds, right? So here I have split these double bonds, right? These double bonds, and then it becomes two products. The first product is this product, and this is the second product, right? And then you have to identify, right? So this carbon atom attach single bondly with hydrogen atoms, right? And attached to the alkyl groups here, and while this carbon atom is attached with two hydrogen groups single bondly, right? So you can write like this, and then the final steps, you have to identify the products, right? So when carbon atoms attach single bondly with hydrogen and alkyl or hydrocarbon groups, the oxidized product will be C double bond O attached to the OH group and hydrocarbon or alkyl groups, right? And while the CH2, the product of this molecule when it oxidizes is CO2 plus H2O, or you can ignore the H2O, and yeah, after that you just have to write the alkyl group here. So eliminate the I mean substitute the R letter by the real alkyl groups. And yeah, these are the final products. Okay, uh, let's take one question again. So, which of these will be split into two organic compounds, but containing ketone group when treated with hot potassium manganate? So there are three options here. So let's check one by one. Okay, first I want to check the option one. So split the double bond like this, and then identify the element, right? So for identifying the element, I think you just have to focus with the main carbon hydrocarbon atom. I mean, you don't have to draw the real alkyl carbon here or the hydrocarbon atom here, but just focus with the double bond with the broken double bond carbon atom, right? So just draw like this, and as you can see that you I think you might be know that uh, this will be containing two organic compounds, right? As you can see here, this is the first product and this is the second product. After that, yeah, you just have to identify the product. So here, right here is C double bond O attached to OH, and here C double bond O attached to two hydrocarbon atoms. So this is the first product, right? In here, in the first product, it contains one carboxylic acid group and one ketone group, right? And in the second product, it is the same. It contains one ketone group and one carboxylic acid. So it is fully the syarat-syarat. So option one is correct. Let's move. So check option two. Okay, alright. First, you have to split the double bond. Okay, but remember that you know when you split this double bond, it is so the product of this molecule when it oxidizes is just same with the single organic compounds. So yeah, you don't have to uh, think so far. Yeah, just focus with the main question. When you know the product is single organic compound, so it means that option 2 is incorrect. Okay, so option 1 is correct and option 2 is incorrect. Next. So yes, this is the option 3, last option, right? First, split the double bond, okay? And second, you have to identify the element like this. And finally, you have to identify the products, right? In the first product, there are just two carboxylic acid groups, but in the second product, there are two ketone groups, right? So this molecule is not fully the permission of the question. So yeah, option 3 is incorrect. Finish.
So this is from ES level past paper, Chemistry 2014, October-November, paper 11. Number 30. Beta-carotene is responsible for the orange color of carrots. Beta-carotene is oxidized by hot concentrated acidified KMnO4. When an individual molecule of beta-carotene is oxidized in this way, many product molecules are formed. So how many of these product molecules contain a ketone functional group? As we know that the general structure of ketone is like this. There are two R groups, carbon atom and double bond. We need to focus on the carbon atom in double bonds which have two carbon atoms attached to each of them. In these big molecules, there are 8 carbon atoms in double bonds which are able to form ketone functional groups once oxidized by KMnO4. This one, this 2, this is 3, 4, 5, 6, 7, and the last 8. I'm going to make the box between them because these two boxes contain two ketone groups each. When these double bonds are broken, 6 product molecules containing ketone functional group will be produced. 4 of these contain one ketone group, whereas the other 2 boxes contain 2 ketone groups each. So the answer is 1, 2, 3, 4, 5, 6. So the answer is 6B. So the next question. This is the 3-methyl hex 3Na molecules. 8 molecules oxidized by KMnO4 in hot concentration. So the question is, what is the product they are? The very first thing we need to do is to break the double bond. This is the key, and it's the very important things to break the double bonds and separate them to know what the products they are. So the first products will be like this. Pardon my bad drawings. This is ketone, and the second product is carboxylic acid. Carboxylic acid. Hopefully you can understand.
Part 2. Exercise. So here I have a question which from past paper 2015, question paper number 13. Alkane X has molecular formula C4H10. X react with chloride in the presence of sunlight to produce only 2 different monochloroalkanes, C4H9Cl. Both of these monochloroalkanes produce the same alkene. Why? And no other organic products. When they are treated with hot ethanolic KOHA, what is produced when Y is treated with hot concentrated acidified KMnO4? So here, alkene X is a 2-methylpropane. It undergoes free radical substitution with chloride in sunlight to produce 1-chloro-2-methylpropane and 2-chloro-2-methylpropane. Both of these compounds, after undergoing dehydrohalogenation, produce the same alkene 2-methylprop-1N. Alkene X has to be a branched compound in order for the same alkene to be produced from the two different monochloroalkanes. If alkane X were not branched, there would be two possible alkenes produced, which is this one and this one. This shows an example of an unbranched alkene X forming two possible monochloroalkanes and then two different alkenes. Two different alkene would also be produced if the second and the third hydrogen atoms were substituted by chlorine instead of the first and the second. Thus, the compound must be branched to obtain the same alkene from the monochloroalkenes. The alkene produced undergoes vigorous oxidation with hot concentrated acidified KMNO4 to produce CO2 and CH3COCH3. So the answer is B. So here I have another question which from past paper 2015, question paper 11. Compound K contains 3 double bonds per molecule. Which bond X or Y will be ruptured by hot concentrated acidified KMNO4 and how many lone pair of electrons are present in one molecule of K? So here each oxygen atom has 2 lone pair. This one and this one. There are 2 of them. Hence molecule K has 6 lone pair. Bond X will be broken when alkene molecule undergoes vigorous oxidation with hot concentrated acidified KMNO4. This bond X will be broken. Y is a ketone. Therefore, it cannot be oxidized. So the answer is B. Bond ruptured by hot concentrated acidified KMNO4 will be X, and the number of lone pair is 6.
Thank you for your attention.
So we hope that our presentation could help you guys to understand the topic itself.
Wassalamualaikum
warahmatullahi
warahmatullahi wabarakatuh.
wabarakatuh.
Cheers from group 2.